Hello everyone. In the previous video, we have learned about the classes and structs in C language or C++ language. And in this video, we will learn about inheritance. So let's start. So in the previous video, I have taken the example of the class box, right? So what is box? Box is a 3D object, right? And there can be many type of 3D primitives like the sphere, cylinder, or box, right? That means all these things like the class we have another class called sphere, and we have also another class, let's call it cylinder, and we have to also add the semicolon here, don't forget it. Okay, so all these types are 3D object. All these types are 3D object. Okay, so these three classes belongs to the same type of thing, and that type is a 3D object. That means we can create a base class and derive all the properties of this 3D object into each of these three objects, right? Into each of these three objects. That is the box, sphere, and cylinder, right? For example, a 3D object has a bounding box, and suppose that we want to render all of these objects into our scene. Imagine you are making a game in which you have to render each of these three objects, and there are some common properties in each of these objects, that is the position of these objects, and the scale and the rotation of these objects. So you have to, for example, let's create a new class like the rotation, right? And public, or maybe let's create struct. It doesn't matter whether you would say that you have to declare a class or a struct for data. If you want to store some data, or if you want to store some heterogeneous types of variables. Heterogeneous means that all the types in the struct or the class are of different types. That means these are not the homogeneous, as it is the case of the arrays. In contrast to the arrays, struct can contain heterogeneous data. On the other hand, array just can only contain homogeneous data. That means all the element must be of a single type only. You can't just store float and int in an array. This is not possible, but it is possible in struct and also classes. So when it comes to storing data, then you should prefer to use struct. In the languages like C sharp, you have to store, if you want to store some data, then you must have to use value types, that is struct. But in C++, all of these classes and structs are value types, and the pointers are reference type essentially. Let's create this struct, and let's call this point or something point, and it will have the members float x, y, z. Or we can also create like this vector3. As in Unity engine, if you have ever used, then you will notice that vector3 contains three types of variables. This is x, y, z, and each of these have the float data type. Okay, so we have the vector3, which is called the position. So let's create public vector3 position. Okay, likewise we can also create struct quaternion or the Euler angle rotation also, but here just for the simplicity we are just taking the vector3 position. Okay, now let's create another variables position. Okay, vector3 position. Okay, now you can see that we have the same copy, right? There is something called common in each of these classes. So that is why there is inheritance comes in, and you can take much more advantage of inheritance. There are much more things to do with inheritance. There is interfaces and the abstract classes. So let's continue with this. There are much more things like that. For example, if you want to render these objects, so you have to call the function render, right? So let's render, and also render, and here also render. Okay, there is two things common in each of these classes, is The first one is the position and the render functions, and there can be much more thing, as I've already said, that the quaternions and the scale, right? So that is why you would need inheritance, that you just have to create a base class that would contain all of this common data or the functions, right? And then you can derive each of these classes from that base class. And now let's create the base class. So let's create, and that base class must be a 3D object. So let's create the object 3D. You must note that this is a valid identifier, right? If you declare this object like this one, it will not be valid because an identifier must not start with a digit, but here it is starting with digit. Therefore, you can't do this. So we will not prefix here, but we will suffix here. Okay. So this is our base class, and it will contain all the data, all the functions that are common in the childs, which these classes are also called childs or maybe siblings, right? So what is the difference between the child and siblings is not just obvious, but you can think of that there is something called the inheritance level. That means this class derived from this object 3D, and you can also have some more objects in the 3D world that are type of box. You can also suppose that a thing or object which has a shape of box, then you can derive it from this class. That means there will be multiple level of inheritance. The classes which are on the same level of inheritance are called siblings of the base class from which they are derived. So this is what's the difference between the child and the sibling. Okay, so let's put all the common data. Let's public the vector3 position here and void render. Okay, now we can delete all this thing. Okay, now how we tell this box type to derive all these properties or the members from this type. So in the C++, you have to put a colon after the type name, and then you have to specify the name of that type from which you want to derive. Okay, so let's object 3D. And just one more thing, it is not that complete. You must have to also specify the access mode of these properties or members. For example, these properties are public inside this class. But what happens when these properties get copied into this class? So we must also have to specify the access specifier here. So let's call it public, right? We are publicly accessing or just copying or deriving from this class, okay? We are just done. Now let's include all these things here. Okay, now let's provide the definition of this render function, and we will do that outside the class by just typing the void and then the name of this class, object 3D, and then the scope resolution operator render. Okay, now let's add some message rendering. Okay, so let's include the header file. We have forgotten it, biostream, and make sure that not to include extension in case of C++ header file. But if you are including a C header file, then you must have to include .h extension. Okay, so we are almost done, and also don't forget to add this semicolon here. Okay, everything is now correct. Now let's create the entry point. Okay, let's create the instance of this box, and let's call the function render. Note that this function is not declared or defined in this box class, but we are just calling here. Why? Because this box class, it will derive all these functions and the variables inside itself. Now let's compile. And the name of our source file is example.c. Let's create the object file example.o. And now let's create the executable. The name of our executable would be app. Let's run it. Now you can see that rendering. It is calling rendering. Now you can also instantiate the sphere object, sphere, and the cylinder. Okay, by mistake. Let's call dot render and then cylinder dot render. Let's again compile it. But we are done. So the rendering function is called 3 times for each of these 3 objects. So let's do some more stuff. We are instantiating the box, sphere, and cylinder. And note that the box, sphere, cylinder will have different kind of parameters. A box is defined by 3 variables, that is the size in each of these 3 dimensions. And a sphere is defined by just only one variable, that is the radius. And cylinder is defined by 2 variables, that is the radius and the height. For example, we want here is that let's 4 5 6, and for the sphere we have to just pass the single variable, and for the cylinder we will have to pass the 2 3, just 2 variable, which is first the radius and the second the height. How we can do that? This is all possible with the help of constructors. We have to define constructors for each of these. We can just only implement the rendering functionality in this object 3D. And now let's create the constructors for each of these objects. So first of all, the box, public box, const float, and we have the x, const float, y, and the const float z. Okay. And for this sphere, let's const float radius. Okay. And for cylinder, let's const float radius and const float height. Okay. And we will also have to define these constructors outside the classes. You can also define the definition of these constructors inside the classes, but just for the sake of learning, we will define all these constructors outside the classes. So let's box const float x, const float y, const float z. And note that we must have some kind of data variables inside each of these objects, because sphere, cylinder, and box, each of these have different kind of parameters. To store these parameter values, we must have some kind of parametric variables. So let's declare it in the private section. Private float radius. And we also have to declare here private float, and the x, float y, float z. And you can also declare here vector 3 type. So here we have to assign each of these parameters of this box. So let's extract the symbol x from this box definition. And note that I am using here this keyword, and if you don't know about this, then you can check out my previous video. I have given the link in the description. This and indirection operator x equals to x, and this y equals to y, and this z equals to z. And note that why we are using this keyword, because there can be a naming conflict, or there can be assignment of to itself. That means the compiler will throw an error that you are assigning x to itself, but we are not supposed to do this. We want just to assign the member variables which has the same name as this, right? So let's for the sphere, const float radius, and this radius equals to radius. For the cylinder, const float radius, const float height, and this radius equals to radius, and this height set equals to height. And also we have to print some message so that we can have better understanding. Okay, box is instantiated with dimensions, or just with dimensions. This x and y and z and at last std and line. Okay, std cout. Sphere is instantiated with radius, std and line. And at last, for the cylinder is instantiated with radius and height, and height. Okay, now let's check whether we are doing right or not. So some of these things we haven't defined here. Let's float radius, float height, and we have the radius, and this, everything is looking fine enough. Now let's compile it before leaving this video. Okay, so this object file is compiled successfully. Now let's link this. Okay, now you can see that the box is instantiated with dimensions 4, 5, 6, and sphere is instantiated with the radius of 2, and cylinder is instantiated with the radius 2 and height 3, and we have forgotten to include here space, but it doesn't matter. So this is pretty much for this video. I will meet you in the next video. We will learn more about the virtual functions and inheritance, and also interfaces and abstract classes.